everyone. I see a lot of new names. It would be amazing if I can see your faces. It would be easy for me to connect with you by face. Everyone. Hi, Rishabh.
Hello,
Hi,
Sanjeev.
Sanjeev.
Hello. Hi,
Hi,
Atul. Hi,
Sanjeev.
Rama. Hi, Joydeep.
Hi, Sanjeev.
Hi, Sanjeev.
So nice to see excited people trying to learn complex stuff.
Hello, everyone.
Hello, Saurabh.
Hello.
Hey, guys.
Hello.
Let's give another.
मैं आपसे एक मिनट मेरी जो है डेवऑप्स की क्लास में शुरू हो गई है 11:30 बजे। मैं इसको लॉगिन कर देता।
Hi, Sanjeev.
Hello. Okay, what we will do is I see a lot of new people joining. So
hello. Sorry, team. Just I was trying to unmute myself. Yeah.
Okay.
Yeah. This is like I will start the video even to show myself. Yeah.
So
here we go.
Yep. Thanks,
And
Alex.
Sanjeev, just to start, can you make me a co-host, or I'm not sure?
1 second.
Because I cannot mute anyone if I want to.
Co-host. Yep.
Yeah. Thank you.
Yeah. So we have given 5 minutes time to everyone so that they can join. So this is more of a kickoff call, and to help you guys understand how we run the program. If a lot of new people, new faces are there, how we do it differently, how you can benefit from the program overall, and what sort of benefits are there in this program compared to some other programs or some other feedback that we have got from our learners. So let me share my screen and show you what we want to do over the next few weeks. I'm not sure which screen will eventually.
I can see your presenter screen, Sanjeev.
Okay.
Yep, that's good.
Okay, so this is the kickoff session. Welcome everyone. I'll run you through how we run it, what sort of challenges that different roles, different people are facing, and let me know. You guys have the option to unmute yourself and ask a question anytime, but see if you can raise your hand, and then I'll probably ask everyone in that sequence to ask questions. Chat is something we do monitor. Saurabh will help me run through the responding in the chat, but there might be delay and that sort of thing. So just unmute yourself and asking that, but make sure you mute yourself after that. So first, I want to address this concern that a lot of people have what DevOps is, and they straight away get into hundreds of tools, technologies, and processes. People will say that, oh, it's a process, it's set of tools, you have to integrate and all that. And when you look at the tools, there are just so many of them. So very common scenario, I'm sure you all, even after some experience, people still get an idea that that these are set of tools and you have to learn them. Yes, you have to, but there is more to it. Just learning tools. It's a little bit about mindset. So I'll tell you, when I started learning DevOps, by chance or luckily or whatever, the role that I was playing were not of a DevOps engineer to start with. So I was talking to a lot of customers and I was performing assessments for them, that where they should invest their DevOps initiative, or where they should be, which tools they should be selecting, or are they actually doing DevOps, or which applications they should be doing DevOps on. So a lot of such assessments I performed. So I was not looking at their actual tools related stuff that much. It was more of understanding, are they ready for DevOps, to what level they are doing Agile, to what level they are adopting these DevOps practices. So that helped me build that mindset from very early stage. And that's something I want everybody to do before we get into all the complexities of the tools and technologies. So I'll maybe leave you guys at the end with a short assignment to work on. That will give you a little bit idea. I don't want to give you a complete assessment for an organization, but that will give you some sort of idea how to build that mindset when managing DevOps related projects or DevOps and cloud related projects. So you would have seen that in medical systems or in any other industry, there are various specialists for different type of activities. But it's only a DevOps expert. He has to know pretty much everything. He has to know so many tools. He has to understand the organization process, uh, security, cost, and whatnot. Like even a basic or even a sort of junior DevOps engineer is expected to know a lot of best practices to work in the cloud. Make sure that everything that he's doing is in compliance with the regulations and all that. So, which is usually in any industry you would expect something from architect level, but in DevOps and cloud, you will see that even a junior DevOps engineer or DevOps engineer is expected to know quite a lot of it. So it's not just tools, but things related around that DevOps and cloud practice, something like security and cost optimization that I mentioned. So even if you do everything fine, but you create resources which are not really, which are probably overkill for a specific project, even then it's a poor DevOps engineer work that they have done. So it's not a very specialization kind of role. It's more of a generalized role that you should know a little bit of everything. So that kind of mindset you have to build. So these are the two things we spoke about. So before we jump into tools and technologies, it's the mindset, and second, it's not uh, a role of specialization. It's a role of knowing a lot of things, pretty much everything. When somebody's writing source code, somebody is writing a Java.NET application, you don't need to know luckily that part that well. But whatever he is writing, until that goes into production, monitoring of that, everything. So DevOps engineer has to know a lot or most of the stages in this entire process. So in these two ways, it's a little bit what do you call it? It's a challenging, because from tools point of view and from process, these things there are so many options. At the same time, it's not a very limited thing that you write some code and maybe test it and you call it done. No, that's not the end for a DevOps role. That sometimes is the beginning. You pick up something where this developer has written the code, and then you move it to all the environments, testing, integration, and all that. So these are the two challenges that I have seen. You guys can let me know if there are more to it. So we need to have a DevOps mindset, not just a tool mindset. So what exactly is DevOps mindset? We'll go briefly into that slowly. So at very high level, you would have seen various pipeline structure of an application that you do a bit of planning, you or an application team does a bit of coding, you want to build that project on regular basis from multiple developers, sort of build process, testing has to be performed, release has to happen in non-prod and prod environments, deployments have to happen. Then you operate it, monitor it, observe it, and then at some stage the application is decommissioned after a few years. This is the overall DevOps structure, but again, we didn't talk about tool over here. So what is that that DevOps mindset? So DevOps mindset is when you have been given a project or you have been given any kind of assignment to enable DevOps or enable automation in any organization, you don't jump to the tools. You should start thinking as a DevOps engineer what the organization wants to be, where they are, and then you suggest them something. That is the sort of DevOps mindset you need to have. You don't jump onto something like, let's start using Jenkins. Probably that's right for the company. Probably that's not the right tool or technology or process for that organization. Maybe they have just, for example, they just have a single developer in the company. There's just one dev. So do you really need a CI/CD continuous integration or that sort of process? Maybe not. So you don't suggest all these tools, technologies, unless you have assessed them, unless you understand the situation, what the organization wants you to do. Obviously, it's not always a single engineer scenario. So then you get further into where they are today. Are they ready to do CI/CD, or are they ready to start implementing DevOps related projects? Based on that, you make suggestions and you do your implementation. So that this is all about maybe a brief but pretty much a DevOps mindset that I wanted to cover, so that you know that before you make any kind of recommendations, you should think from that customer's current situation point of view and then make some sort of recommendations. I'll talk about a very basic scenario that another problem that people face is that there are so many type of applications. Mainly, I have classified them into two kind of applications: custom apps, which can be Java, PHP, .NET, any kind of modern JavaScript framework, maybe Python. Maybe there are mobile applications for your iOS and Android devices. Those are custom applications which any organization builds within that company. So they have developers doing all these activities. And you are expected to do DevOps, or you are expected to enhance DevOps capabilities for such a project or for such an organization or for such a application in a company. Then the second kind of applications that you will usually deal with is commercial off-the-shelf applications: Oracle, Salesforce, SAP, and so many. There, TIBCO, and a lot of other possibilities are there where you are buying, or the company is actually, instead of building that, is actually buying it from market. And then there are other types in this, that it is a self-hosted application or it's a SaaS application. That's something second that's within this quotes products. So these two are the kind of applications that you would typically deal with. And this is where the mindset again starts to jump in, that when you look at any kind of application and you have to enable DevOps and cloud for that application, you need to start thinking instead of focusing too much that how a Java application is built and trying to discover it yourself. The mindset should be that, are you able to communicate with the developers to understand how they are building that application? They may have looked for keywords or opportunities, that are they able to build it through some CLI process? Is there a command to do that? Now, to run that command, there may be some packages have to be installed. Right now, we don't know what that is. For Python, you may have to have a specific version of Python that has to be installed, and then you run certain commands to build a specific application. It could be an entry point of your Python application. It could be a Java application. Then you need to understand that to build that application, you need to have some sort of software that will build that application. So that has to be available to you. Then there have to have some sort of CLI commands that you can run that will build that application. So you need to have maybe Java running environment where you a JDK, and then you have to build it, or Maven, or for .NET, maybe you need Microsoft Build or something. You don't have to know all of it right now. What mindset is that you need to know that to build any application, these are the 2 or 3 things you would need, and you will work with the developers to get that information. That's why I tell everyone, a lot of people reach out that how much of coding will be needed. Maybe you don't need that much of coding, or you don't have to be expert in Java. It's good if you have knowledge, that always adds value. But from that mindset point of view, you should be ready to talk to a developer, tell them that I understand you are writing an application in such and such technology. How do you build it? What sort of runtime is needed to build your product? Same applies for the other off-the-shelf products. What sort of APIs are available in that product? How can I, because these are some of the things you would probably be using in your entire DevOps process. Maybe some sort of APIs, how you can automate it. Maybe some sort of CLI process you can automate. So look for those opportunities. Look for what you would talk to the developers. You can be unprepared in such discussions. The only preparation you need is the right mindset and the right questions to ask. You cannot ask random questions about the application, or something you don't have to worry about. Like, you have to be very specific that I need to understand what should be available for building this application, what are the APIs and CLI commands that I can use to build these applications. Then you have the option of either building it on your own laptop first and fine-tuning those activities, and then building a CI/CD process around it. Or it could be you straight away jump onto a CI/CD tool or technology that you have after you have gathered all the information. So this is what I wanted to show in this diagram, that you need to, we didn't discuss so much on the SAP and the other product. In commercial off-the-shelf product, the mindset is slightly different. You are not building the application within the organization. So the coding and the development is not so relevant here. It's, in this case, you need to understand a little bit about that product. You have to do some research online on that product's website to see if they offer some sort of DevOps capabilities. Then you leverage those capabilities. Because sometimes these products have also understood the DevOps need and customers needing that kind of support. So they will build some sort of CI/CD capabilities or some sort of Git repository mechanism within that product. If not available, then you need to talk to the vendor to understand if it is some random quotes product. which is not so popular, does not have a lot of documentation, then you need to work with the vendors to understand how you can enable it through CLI and other activities. We'll go more deep into all these, why we need CLI only, why we can't have click operations and click kind of thing. And that's not how we want to build the application. We want to build it on a platform, something like Jenkins or GitLab or other products, which respect APIs and CLI commands. All our servers are Linux driven, so we don't need any sort of UI interventions in our processes. So look for CLI API sort of thing. Another angle to look at it is the customers will provide you projects or assignments to work on. You can look at from an assessment point of view where they lack, where you are adding value. So some of the, instead of learning these different tools, you can also try to learn them through different capabilities. So is the organization managing the source code in a Git or in a repository where multiple people can access it? You need to know some sort of operating systems basics. Then you need to know a bit of continuous integration. If you are not able to understand, then we will deep dive into all these topics in our future sessions. I'm expecting that by now you would have a very high level understanding of these terms. So you look at how the company is already doing the CI/CD, the continuous integration process. Continuous integration process is where multiple developers are frequently writing source code, which is then integrated, and you are provided some sort of feedback that is the source code. Are you able to build it properly? There are infrastructure provisioning point of view. You can learn more on this. You can use different tools, Terraform and other tools to relate to it. You can, so this point number 3 is more of creating maybe EC2 instances in cloud. Then point 4 would be configuration management. On top of that EC2 instances, you have to deploy your application. You have to deploy some sort of middleware components. That comes under configuration management aspect of DevOps. Then certain applications can be containerized. They can be packaged. We have dedicated sessions on Docker and Kubernetes. So they will, once you containerize applications, and how do you orchestrate them? Then you have continuous deployment strategies, release automation point of view to learn. So these are different capabilities I'm saying, so that you can learn them in isolation as well if you want to. Then obviously the one you need to learn at least one or maybe two cloud platforms. Then comes the latest beast in the industry where a lot of money, a lot of jobs, opportunities are there, which are operations in cloud. A lot of migration to DevOps, to cloud has already happened. I believe companies are a little mature now, but when it comes to operations, they still need a lot of help in terms of scaling the infrastructure, disaster recovery, monitoring, observability, alerts, security and compliance. So companies have come to cloud, and now the auditors are knocking the door. They are asking, your application is not compliant. You are not following some of the best practices that we want. It could be maybe some sort of exchange. It like maybe if the product is, the company is listed on stock exchange, then exchange has different compliance. If it's a bank, banks have different regulatory compliances to meet. So this is where companies are struggling. Cost optimization. Now again, companies have come to the cloud, but the cost that they thought it would be, it's not exactly the same. So the architects and the engineers they hired did not focus too much when migrating to cloud. And now this is another activity that you can learn and you can help your customers. So instead of learning DevOps and cloud just through tools, you can focus on these individual areas. There could be one or two more things that can be easily added to this, but I wanted to keep it brief for today. So you can also learn through these activities as well, where the customers are facing problems or companies are trying to move in that direction. For example, containerization. You can easily pick up this as a capability and learn it. I'll request everyone to work on a small sort of assignment which will help you build this mindset. Very simple assignment. I need you guys to maybe write 5 questions or few questions for each capability that you would ask the developers or any other counterpart in your organization. So for example, you have been asked to optimize the cost in your cloud. What are the few questions you would have that you will go instead of asking some random questions? We just need maybe few 5 questions which you would be having handy with. You haven't been told which cloud platform, you haven't been told how many applications, you haven't been told whether they are Java.NET. So do you really need to know if they are Java.NET applications to optimize cost? Maybe not so much. Do you need to know whether it's a Java or .NET application for a CI/CD process? Maybe yes. So we need those 4 or 5 draft questions that are readily available that checks your mindset towards DevOps and cloud projects. So take help from ChatGPT. You can easily put it in ChatGPT and get the responses. And I already have some spreadsheets that I can share, but I want you guys to do that research, do that part slightly so that you also get an idea that when you go into an organization or any interview, excuse me, there is not complete information is available on day 1 to you. What is that key questions? What are those key things you will ask in your company to different people that will help you understand the entire landscape of that company? That is something I want you guys to work on. Next week, I'll share my analysis and my stuff as well. But it is something I need your help as well, that you work on this. So some of the things from tools point of view that we need to know, and something that we will be covering in this program is around Git and Linux is something every DevOps engineer will have to work on day in, day out. So you need to know these. These are sort of mandatory. From the second column, you can pick, maybe it should be one strong orchestrator that you need to pick. GitLab, Jenkins, Azure DevOps, GitHub Actions, and we will probably cover all of them, but in different stages. Some of them while we are learning it, maybe Jenkins to start with, some of them when we go into projects. And these in the center, you will see a lot of tools which are commonly used. We will have to learn pretty much all of them. HashiCorp, Terraform, Docker, Kubernetes, Ansible, Packer, a bit of ML ops nowadays for people who are into data, GitOps, Atlassian, Jira, or the agile process you need to know. And the observability is something we will cover in detail. So what's happening in your entire system? How are you monitoring it? And then you can pick up AWS, Azure, or Google Cloud if you want to. And these are some of the things we are going to cover over the next few months. So we'll start with DevOps sessions. We'll start with very basic Git, Linux related sessions, how to build an applications, perform CI/CD activities, Docker and Kubernetes, which is your containerization capability, Terraform and Ansible, which is your infrastructure provisioning and configuration management. We'll spend a lot of time on AWS Cloud. We just recently finished our Azure Bootcamp. So we'll give opportunity to AWS now. Then we jump on to projects. So within these uh, thing, within all of these sessions, uh, there would be small assignments is something we will be giving. For example, this is a very simple assignment, would probably take few hours for someone who is expert, but for someone who is starting, it may sound very boring to start with, that what questions I have to prepare, but then it will prepare you for long term, that in any unknown environment you go, how do you start your conversations? DevOps and cloud roles are not regular roles, I would say, where you are given tasks and you resolve these tickets. In these roles, you have to find work, you have to find opportunities, you have to find issues, and then through automation, through you first basically create those tickets and then when you close them also. So you need to find them. You need to be speaking to various stakeholders. So it is all about talking, and this small assignment will prepare you for those talking points. What you should be asking. Otherwise, you wouldn't know what to ask. You would expect somebody will give you a task to work on. Usually these roles are, you find the task, you find the opportunity, you find the issues in the environment, and you automate that, not waiting for someone to give you those activities. So this is very crucial assignment. So in all these sessions, there would be small assignments that you would be expected to work on. And because it's a group, you all are connected through Slack. You can share your thoughts. You can conduct sessions if you want to. Slack allows to conduct live calls also. So everything is possible. So keep sharing as much as possible in the Slack with each other, whether you accomplished something or you have doubts. It's not only when you have doubts, when you have achieved something, you have understood something, just openly share it that these are my findings. That would also help and motivate others. And how would you benefit from this entire program? So it's obviously it's not just making the payment and attending the sessions. That's probably a 10-15% of the benefit. By attending it, if I'm delivering 100 concepts, you will probably remember 10-15% of it if you only attend the sessions. Working on those small assignments will increase your potential of reaching the knowledge to maybe 50% overall, because these assignments are smaller in nature. These assignments are so that you can finish it in 1 week at max. The maximum benefit will be once you apply this knowledge from attending these sessions and those assignments into complex projects, that you are able to finish a complex assignment, which we have 4 or 5 such projects already. So are you able to apply that knowledge and build those projects? That would give you 90% of success rate. And the remaining 10% is, are you able to explain what you have done in your projects and in your assignments? Are you able to articulate that? Are you able to explain it to someone who has no idea about that project and he is able to get some concepts out of based on your discussion? And are you able to answer some of the questions if you are asked? That would pretty much how we have learned DevOps and cloud, and that's how we suggest. It's not just watching videos or watching sessions. It's by working on small assignments to give you confidence, working on complex projects to make sure you can manage a complex environment. And then last is that you can explain your concepts. You can explain those projects too. And we'll give you opportunities in this program. We will be asking you to do demos. We will force you to do demos. We will make sure that you have to work on these things. And obviously, I will try to help in monetization way or so that if you are helping us, if you are basically helping yourself to build those projects and then demonstrating those projects. We will try to make sure that you are not charged for that. We will try to give you credits for AWS, and we are trying if we can get more for Azure as well. But for now, we have AWS credits available, but we'll give it selectively to people who have demonstrated the projects and the assignments on a regular basis. These are not available to everyone who joins the program, but people who do professionally demo of the projects and the assignments on regular basis. So that's something we never committed, but we are offering it. Recordings of previous batches are also available. Recording of every session will be available to you guys. Whether you join, miss, or don't miss it, recordings will be available for you to refer. And I think the last point I wanted to say was that that hands-on. There's no alternate to that. It just has to be a combination of learning and hands-on. So there is no compromise on that stand. So now you guys can let me know before we get into the other part of today's session. It's more of kickoff, more of briefing about the program. I know Nabil, you have a question, but yeah, that's how we can. Nabil has raised his hand. You guys can raise hand and wait for some time. You always have unmute option, but we would like, just for the continuity of the session, we will there would be appropriate time in every session where you can ask questions, and we'll try to answer them. Yes, Nabil, how can I help?
Yeah, thank you. I just have two questions. One is related to the assignment itself. Maybe I need just more clarification. Yeah, I got the overall idea. And the second one is related to the projects, because I am more related to the Azure stuff. So my expectation was around the Azure. Yes, in my environment, there are some projects around the AWS, or in the company we're using AWS, but actually I have more focus on Azure stuff. So I'm not sure if up to what extent it will be covered. Maybe I will have specific assignments that will touch the Azure if there is a possibility for that.
Okay.
Yes, these are the two areas: the assignment and more focus on Azure stuff. Thank you.
Let's address the Azure second part first. From Azure Cloud Learning point of view, we have just finished it. In our last batch was around Azure. In the last week also, we were working on Azure project. So that recording is always available. So that can be a good starting point. Remaining of the projects that we have, although we have built it on AWS, the remaining 3 projects, but again, the focus is not so much on the AWS or the tools and the technologies. The focus is on the overall mindset and the overall the concepts basically. So cloud concepts, cloud computing, whether it is containerization, Kubernetes. So you can always build all those projects on Azure as well. Although my demonstrations are on AWS, but from securing your infrastructure or managing multiple AWS accounts, or all those concepts are still relevant for Azure as well. So you can always build those projects on that platform.
Yeah, so this means that I can map what I will understand across. So it's not like focusing on AWS and the discussion will go deeper with the AWS as a concept or whatever is around the AWS. This is something that it is generic that I can take and apply toward the Azure. Yeah, makes sense.
Absolutely.
Yeah.
Obviously, there would be challenges. It's not direct one-to-one map all the time, but our focus has been always on concepts. rather than on a specific cloud or a tool. So we said all the assignments that we will give you after some time would be build this project on any CI/CD tool or build this on maybe AWS or Azure uh, platform. So right now they will start with a specific tool and cloud in our learning phase, but after a while we will say use any cloud of your choice, use any CI/CD process of your choice, achieve these activities. So that's how it will be.
And I do have the flexibility to come with, let's say, the stuff that we'll understand and apply it to Azure and share it with you for, let's
Yes,
say, assessment or discussion,
absolutely.
because I might not have that much time to invest on AWS, either for my job or my normal time. Yeah. So there is a room for maybe applying the concepts toward the Azure and then making a discussion around that.
Absolutely.
Correct?
So even
Yeah,
though
okay.
I cover a lot of AWS and all complex scenarios, we also already have uh, cloud architects who have extensive experience on Azure within our mentorship program, who will help us on any Azure related stuff or that sort of thing.
Okay. Yeah, the first question was the assignment. Yeah.
Okay. The assignment, so what we want in this simple assignment is to write down some questions that you would take to the developer or your other stakeholders to understand that organization. So you have been asked to work on, say, a continuous integration process or CI activity for your organization. So um, you have been asked to do DevOps. I'm not going too deep into everything because not everybody understands it, but I'm saying layman language is like you have been asked to do DevOps, which is not a very right sort of language, but assuming you have been asked to do DevOps for a .NET application, what would you ask the developers? You don't know .NET that much. You have been asked to do CI/CD for a project which is API driven. It doesn't have a user interface, does not have any such thing. So what would be those 4 or 5 questions you would ask them? Similarly goes for other things. You have been asked to implement DevSecOps, or you have been asked to implement cost optimization. So what would be those 4 or 5 questions you would take it to your customers? Obviously, not everybody will understand it at this stage, but people who, even if they have 6 months, 1 year, some sort of exposure to DevOps and cloud, they should be able to find it online as to what those questions should be. And then we'll brainstorm on it. And once we discuss it, then everybody in the group will be aware that for a good uh, DevOps engineer, you need to find out about your environment. You need to do research and get the information about your environment. So that finding activity is what we're trying to accomplish here.
Okay, thank you.
That the discovery activity, that how do you discover? That
Yeah.
is the activity we want to focus on.
As you mentioned, the role itself, it is not like a task assignment. I need to explore, I need to open to myself like opportunities because I'm coming from like cloud architecture perspective. So this role also doesn't have a task. You are not an operational guy that you will be given this task and the outcome is very well known, but it is more about exploring, knocking the doors, reaching out to the stakeholders, as you mentioned. Yeah, so I get the idea. Thank you, Sajid.
Anybody else has any question so far, or they are not clear about the program or anything else?
Hi Sanjeev. My
Hello,
name is
Sanjeev.
Sanjeev.
Raise your hand. That will allow us to know who wanted to speak first. Yes, Atul.
Okay. Hello, Sanjeev. Yeah. So my question is like let's say we are covering some DevOps tools. So what will be the I mean these DevOps tools will be covered from scratch, or what will be the level of difficulty we will be starting, or do you guys expect us to know something, or it will be from the scratch itself, or
It will
how
be
is it
from
going to work?
scratch. It will be from scratch.
Mhm.
But before we jump onto tools, we wanted to work on a little bit on the mindset part. So uh, do the research. What is DevOps role? We want that warm up to be done by you as well before we jump on to start explaining what is DevOps. So you always you it starts with your efforts basically. So we want to make sure that you are aligned with the program. We don't want to start with what we know and then we guide you. That's always possible.
Yeah.
But we want to warm you up. We want to uh, be prepared that what kind of assignments you are expected to work on or things that you should be discovering. That it's all about finding out things rather than we explaining you something and then you just know that subset of things. So I think that's something we want to drive rather than we just delivering sessions. But yeah, it will be from scratch. We will cover maybe installation of tools. We will cover agile. We will cover all the things that are relevant from very scratch.
Okay, okay. Thank you so much. Thank you.
That probably is one of the uh, disadvantage of the program, that it's a slightly long running, and because we touch upon, we allow asking a lot of questions, a lot of discussions to happen in our program. So things stretch a little bit. So that's why we never committed. It's not suitable for someone who is looking um, the outputs in the next 3-4 weeks. It's not very suitable for that. So it's a 5 to 6 months long program, and we have to consistently every week we have to work on those sort of assignments and things. Then we will be ready with being able to face the industry.
Also, I think this is the best approach that you guys are doing. I mean, no one does like this. Okay, so this is one of its kind type program. Yeah.
Yeah, we try our best so that it's you don't just focus on these activities, but a lot of this knowledge that we talk about in the program, you can even take it on your not just interviews, but at your job, apply that knowledge. Think from how we think for a new project. Uh, Guide your customers based on that rather than being guided by them based on the requirements. So yes, Srinivas, you have
Hi, Sanjeev.
Hi.
Are you able to hear me?
Yes.
Yeah. I saw that course description. I didn't see any language and shell scripting or Python. Nowadays, they are looking for shell scripting or Python, any scripting language.
We
One
will
hour.
not be covering.
Okay.
We are not against, but we think that shell scripting alone is not a very differentiation sort of thing. You will probably never be hired or selected ahead of somebody else because you know shell scripting that much. So shell scripting is just used in some of our projects slightly, and maybe in the Linux you would be given some sort of assignments where the outcome can be produced through shell script, but we will not focus that much on shell scripting. We'll focus on Ansible rather. Ansible
Okay.
is a modern way of writing shell scripting. At the same time, for shell script to work on, say, 1,000 computers, you have to do so many different things uh, for a shell script to run on those many servers. Ansible is answer to shell scripting as well as managing thousands of servers at the same time.
Yeah, I saw some job description. They're asking shell or Python need to be experienced
Say
on it.
yes, absolutely. Don't rely on this program because we will not be covering shell that much. We are that's a day-to-day activity. That's a combination of at very high level, what is shell scripting is a combination of multiple CLI commands. So you can
Okay.
you can build it yourself. So it's
Okay.
not.
Thank you.
But at the same time, all the job descriptions that say shell scripting, you have to say yes. And in interviews or discussions, you have to say yes and move on and explain them that I have used shell script to. We'll give you those examples as well. I have used shell scripting to do these automated tasks. And then obviously, once you have done those assignments, then you can easily justify. Hi, Joydeep.
Hello, Sanjeev. Am I audible?
Yep.
Yeah. I just have another question going back to the assignment, actually. You mentioned to look into the key capabilities and ask questions as if you're going as a consultant and asking a few basic questions to understand your environment or what is required from you. Since you mentioned that DevOps in general doesn't give you opportunities, you have to find it out. Am I right on that?
Yeah, absolutely. That's what I
Yeah.
mentioned.
Going back to the question again, there are like 8 capabilities that you have mentioned. We will be making questions based on those. Now, my question is it going to be generic questions or industry specific questions? Since there are certain options that I can see, like I'm not really, I'm a complete novice, so I'm just going to go and say deployment strategies would definitely depend on industries rather than being generic. So what sort of questions would you say are we asking? Is it a fintech based company or a large manufacturing, or do we have the liberty to choose it, or what kind of questions are you asking for it? Thank you.
Ask that question in one of that. Make sure, like, what we want to say is that question relevant for that ask or not? That's what we want to assess in this. If you can justify that my question is relevant for and there is a basis for me, I will be using this response to decide something for that company, then that's a right question. And you have liberty to write down those many questions. That's why I said at least 5 questions in every category, but you can have 20 if you want to.
So, so just to reiterate, we will be describing a bit about the industry that we are questioning, and then for each and every capabilities, what kind of question are we asking, and what kind of answers should be expected out of us? Is it something
Or
like that?
what you would do based on that? What would you
Oh,
do? Decide.
perfect.
Then
Okay.
that will tell you that is it the
Just to
right
understand,
question? Yeah.
sorry, just to understand the scope of the work that they're looking for, right?
Yeah, absolutely.
Thank you.
All right. If no more questions, then I'll hand it to Saurabh to take it further. Again, it still remains warming up, kickoff session. We are still not going too deep into DevOps and cloud concepts. We just warming up.
All right. Thank you, Sanjeev. So that was a good introduction. So for those who do not know me, my name is Saurabh Porwal. So I work as a cloud architect in Melbourne. I've worked for over 20 years in the industry, and I've been I've worked on multiple roles actually. So I started up as a developer, and then I moved on to configuration management as Dev, and then DevOps engineering. Then I worked as DevOps architect. I worked as cloud architect, enterprise architect, and currently I'm working as a security architect in one of the large organizations. So I have got a lot of experience behind me, and I think that I'll be able to help you guys on that. So today is just an introduction session in continuation with what Sanjeev has just given you a glimpse of what DevOps is. I'm aware that there are many students who are practically very new to the concept. This is a very peculiar batch where we have got some freshers, we have got some intermediate students, we have got some advanced students too. So people who have got around 0 to 3 years of experience, and then we also have between 3 to 12. And there are a few students who are more than 15 years plus of experience. So want to cater to all of them, and that is why we want to start from scratch. So we'll tell you about all the different technologies Sanjeev has just mentioned, and I'll be taking a glimpse of all these tech stacks too. And I'll give you opportunity to ask questions. So I will just share my screen and where is my desktop? Let me see if I can. So Sanjeev, you will have to tell me as to what screen are you seeing at the moment.
Yep, I'm seeing your presentation, but not in full screen. Yep.
Is that in full screen?
Yes, full screen.
All right, thank you. All right, so Sanjeev has already told you about what is DevOps, the set of practices, tools, cultural philosophy. So to be frank, it took me a long time to understand what is the culture. So I have been working on tools throughout a lot for long, many years. And when it came as a culture, so it took me probably more than 6, 8 months to understand what does it actually mean by a culture. Because being a software developer, it's always confusing what is actually a cultural change. So, but it's a set of practices which differentiate DevOps from any other methodology of working. So it's to do with how you actually communicate with the different teams, how you actually communicate with between the development and operations. So let's say if you're a developer, how do you communicate with the operations team? So it all works within the agile methodology. So wherein you've got multiple sprints, you've got multiple iteration cycles, you've got development teams setting up with operation teams, and then trying to do all these deployments and making sure that all the changes that are being deployed, they're iterative. So slowly, once you start working with all these teams together, you've got business processes which are working with agile, and then you've got development teams working with the operations team. All the bits are delivered in incremental changes, so there is no big one massive change that comes as a part of release, and that is where the DevOps is all about. So set of practices, lot many tools, and the culture is all about collaboration. So there are many tools as well which support collaboration. We'll have a look at that as well. But what DevOps benefit is a faster set of delivery, and whatever is and a complete increment in the software. So you do not deliver one big piece of software. You just do incremental changes to a software, and it's very fast delivery. So that is why DevOps has been more popular over these years. And the DevOps engineering is probably now a practice among almost all the organizations. So looking at the dev challenges, so we'll have a look at the dev challenges, we'll have a look at ops challenges. So how did DevOps help anybody? So the dev challenges was that the code deployment time is very high. So if you do any sort of manual deployments, DevOps is all about automation. So the automation to an extent that once you do a code commit, once you have written the code, it can do a lot of things automatically. It can build automatically, deploy automatically, test automatically, deploy in different environments, production. So it helped the developers for a quick deployment of the code. And also the developers, if they were not using the correct configuration management tools in source code tools, so poor code management, they would not know what is actually running in production. So effective code management, and we'll be looking at these code management once we are doing the Git sessions. But that's where it helped the developers. Now, how it helped the operations, the ops challenges where you had difficult maintenance of uptime. So a software, if it is running, sometimes it would go down. Nobody would notice unless there's somebody, customer is complaining or somebody notices that it is down. So a lot of different tools which help you in maintaining the uptime. The other challenges for the ops was that automation tools earlier were not so effective. So now we have got a lot of automation tools doing the server monitoring, continuous monitoring across the different servers, across the different VMs, across a lot of different databases, across many other tech stacks. So we can now have continuous monitoring. And continuous monitoring includes the feedback being given. So feedback can be in terms of how your infrastructure is. It can be in terms of your application challenges. So these are the common set of challenges which helped both the developers and operations. And this is what propelled DevOps into the industry. Now, if you have just explore DevOps on internet, this is the image that you will always see. That it's an infinity type of symbol, always referring to the DevOps image. So this is nothing but a set of practices. So if you start from the planning phase, so which is here. So you plan a software delivery, you start building the code. So you start writing the code either in a version control or source control tool. Once you have written the code, the next part is to always build the code. Now, what does the code build mean? So you write the code in an English language and whatever the program supports, that programming language supports. And then you will have to do a build of the code. So build of the code would mean that you might have to compile the code, execute a binary. So that is what the building means. And this is where the whole CI part comes into picture. When people talk about CI and CD, so this is where your continuous integration comes up. So because once you have written the code, you need to iteratively build the code again and again. So you use a lot of automation tools in it. Once the code is built, you have to test the code. So there are multiple tools which can help you test the code. You also have to do some sort of security scanning, quality control when you are testing the code. And then once you have tested it, you release the code into production. So you can release the code using your CI and the CD process. So we'll be having a look at what CI means and what CD means in detail in the future slides. But then you release the code, you deploy the code into different environments. So you've got a UAT environment, you've got SIT environments, you've got pre-production, production, multiple types of environments depending on how complex a software is. And then once the code is deployed into production, you do that is deployed using your virtualization, containerization. There are multiple ways in which you can deploy the code. So you can either deploy a code directly using a binary, but nowadays most of the applications that you will see, they are microservices, and you use Docker or Kubernetes types of applications to deploy it. And once that is deployed in production, you start monitoring the code. So whatever is the application, there are multiple tools which will help you monitor the application, the infrastructure, the networks, the firewalls, and then the same iteration repeats again. So this is what this means. So, and these iterations happen in an agile way, where you continuously repeat this loop again and again, and then you do small incremental deliveries. Right. Same view using the different tools. So in the coding, you can use Git, Jira, Confluence. So these will help you when you are coding. So Confluence, you can write the documentation. Jira will be used for creating the tasks, creating the epics, stories. So for those who don't know Jira, so it's a project management tool which can help you assign a specific task to someone. Git is the most popular source code management tool now, wherein you write the code in either GitHub or GitLab. We'll be having a look at details in the subsequent sessions on it. So once the code has been written, so you need to build the code. So if it is Java-based code, you use Maven, or if it is Python-based code, you don't need a specific compiler for it, but your Python version should be installed on wherever the host that you are running. Once the code has been written, and once that is built, you can test it using your Selenium JUnit. Now you can release it using Jenkins. So it's a CI tool. The deployments can be done in using Docker, Kubernetes. Deployments can be done on any of these platforms, so AWS, GCP, or you can deploy it in your on-prem infrastructure. Operational tools, you got Docker, you got Ansible, you got Chef, Puppet, any other operational configuration management tools, and then you keep on monitoring the same. So it's the same view of what we saw earlier. So this is your lifecycle view, but this is the same thing in DevOps as a tools view. Now, lots of different tools. Each tool has got a very specific purpose. So, but this is how you do the DevOps. So let me just select up a pen. So the first thing that you start up with your source code. So this is where you start writing your source code. So this source code can be, you can write it on your computer, on your local terminal, and then you can push it onto your Git. So if you just break it down, so this is your Git on your computer, but this is your GitHub, which is your remote server. So this whole thing is used for writing your source code. Now, once your source code has been written, so then you do some validations and commits. So these validations can be validated using your Jira boards or change logs. So you can put in some sort of commit in it. And this is still up till where you are writing the code. Once your code has been written, so it has to go through a build process, because you are still writing your all your code in a programming language. You haven't really done anything to the code yet, right? So the first thing that you do to the code is you start doing the build. So if you're writing a Java code, it's similar to how you compile on your machine. So let's say if you have just written a small program, yeah, you can use Java C and then you compile it, right? So that's the build. So output of the build is always a binary file. So something which is not human readable. When I say always, most of the times. So you will find that these are the artifacts that are the software application artifacts. So it's no more just an English written language. So and this is an artifact that you have to store up in a repository. Now, once you are doing the build, so the build also can trigger your security lifecycle, so which is a security scanning. So SAST and SCA, so which is software composition analysis and static analysis of the security. So there are multiple tools which can help you. SonarQube is one of the most popular tools. So this is where you start scanning your tools and scanning your code. And then once your code is scanned, then you can publish it. Right. So you're at this point of time, your application is published on some sort of repository. So if it's a microservice, you would use your Docker repository. If it's a binary file, you would be storing it in somewhere in Artifactory or that sort of application. So it's a binary file. So a binary repository where you have a version control of the binary so that you know what exactly is the output of the build that you have done. So this is up till your CI part. So the whole thing that you see up till here is all your CI. So by the time you do the CI, your binary artifact is published onto a repository. And then after your binary is done, so that now is the time for CD, which is your deployments. So you take this binary and then you deploy this binary using a CD tool. So now a CD tool can be either your Docker or your Argo CD, or you can use Helm charts or Kubernetes or any other deployment tool, and then you can deploy your specific binary file onto the different environments. So you've got different environments on here, and then you deploy it. So this is your general software development lifecycle. In the subsequent sessions, we'll be touching up with each and every item that we see that has been cataloged here. Apart from that, so in here, if you see, this is just whatever has been. This is the base of what you do, right? Apart from these, if you see, there are more tools which are required. So for example, you need an authentication tool to log on to your application. So you can use a Keycloak. You need to monitor your applications. You can use Prometheus, Grafana, all these different monitoring tools. You would be using vaults because you cannot write just plain text passwords inside your application. So you would be using some sort of vault. So it can be inside a cloud, or you can use any sort of other vaults like HashiCorp. You would be using some sort of logs and traces aggregator to find out if there are any defects, if there are any bugs, so that you can just do a debugging. Or sometimes you can use AI related, for example, like Splunk, if you are using, you can use AI like tools to identify if there are any forthcoming problems that can potentially cause any issues. So this is what you will be learning in the next subsequent sessions. But this is your overall DevOps workflow. And just so this is your DevOps workflow, which we'll be working through the subsequent sessions. Now, a huge variety of different tools that are in each of these workflow items. So if you see here, okay, where did it go? So it's a typical list. You'll find this list anywhere on the internet, but you don't need to learn each and every tool inside. You'll need to understand. So when you're in the build phase, so you've got your SCM, which is a software configuration management and resource control. So if you just have a good command over any one tool inside each of the category, that should be good enough, because all these skills are intertransferable within each tool set. So for example, when you're doing your SCM, so you would be knowing about your Git, GitHub, GitLab. So all these different tools here. So if you just know one of these, so your skills are interchangeable. You would know very quickly pick up the other tool as well. So similarly, you've got build tools here. So this is your Maven, Gradle. So these are the tools which are used to compile your source code. So any source code that you have written in the SCM and VCS, this is where you compile it. Repositories. So there are JFrog Artifactory, Nexus, NPM. You've got Amazon S3. These are the repositories which will store up your binary files. So whatever that you have built here, these are stored here. So if you know any of these tools among any of these segments, you are covered. In the test phase, so when you're writing up the test cases, so you've got a few browser-related testing tools. So for example, like Selenium, you've got browser sync. There are multiple tools which can be used. So it depends on what sort of application that you're running. You may or may not be involved in understanding the complexities inside each of the tool. But if you have an application that is using Selenium, you should be comfortable with just knowing what Selenium is or what Arma is, just on a very high level. Similarly, if I just browse through, so you've got Black Duck here in terms of security. You've got configuration management tools, so which is a server spec. So in this whole chart, if you just have to pick and choose what are the most important tools that you should be looking at, I would say that you've got Git, Bitbucket, or Git. You would go for either Maven, Packer. In here, repositories would be JFrog Artifactory. For testing tools, if you have an understanding of Selenium, that's okay. You may not need the loading and the performance related tools. Black Duck is good to know, because that is where we'll be discussing a lot about security in the subsequent sessions. So security will be embedded in everywhere. So it's not just about a tool. So, but it's a whole practice in itself, and we'll be dealing with a lot of security related discussions. In deployment, so any of these Puppet, Chef, and Ansible. So we'll be working with Ansible here. Continuous delivery. So it can be either Octopus deploy. So this continuous delivery is being used when you have built your software, you have put your software onto your, let's say, an Artifactory, and then you deploy it into various environments. So we'll be looking at some of the deployment tools. We'll be covering Terraform. We'll be discussing about HashiCorp vaults and any other cloud vaults as well. For runtime, we'll be working with Docker. Orchestration tools will be covering up Kubernetes. So we will be covering up Lambda and serverless. operating systems, runtime. We'll be covering up almost all of them in here. So when we are working with the operating systems and databases. Regarding the alerting and monitoring tools, so we would be working with, I'm not sure if Sumo Logic is in here. So Sumo Logic. So we'll be taking a special session on Sumo Logic. And we'll be also working with AWS alerting and monitoring. So we'll be working with CloudWatch, and we'll also be discussing a lot of Dynatrace, App Dynamics, New Relic, what their capabilities are. So it will all be covered in detail. Management. So these are individual tools which are being used in organizations. So we'll be discussing about Jira as to what are the different types of stories, what is meant by epics. Also, project management, Jira would be covered, and the notification tools. So of course, once your application is deployed, so then these are the notification tools where the user gets notified if something goes wrong, right? So and the collaboration tools. We are anyway using Slack for our program. So this is all the list of DevOps tools, and we will be covering the majority of the tools, which is in here. Now we had a look at the complete DevOps, but when people are saying DevSecOps, what is DevSecOps? So we haven't talked about DevSecOps, but DevSecOps is a complete practice in itself. All the list of tools that you say, there is no tool called as DevSecOps. So DevSecOps is not a tool. Similarly, as DevOps is not a tool. So DevSecOps is also a practice. It's a collaborative thing that is being done. So there is no specific thing that you can say that this is DevSecOps. It's a complete cycle in itself. And what is covered in DevSecOps is so in DevSecOps. So if you see this particular Venn diagram, so you have got a development team here. So you've got operations team, you've got security team, and you've got quality control team, right? So with an intersection of all of these is something that is called as DevSecOps. Now, DevSecOps, there is no one team in an organization that you will find that this is the DevSecOps team and it will do a particular task. DevSecOps is the responsibility of all the teams that are being done. So all the teams that are involved, they will be involved in dealing with security at their end. So for example, when the development team is doing their development, they will incorporate some sort of security mechanisms. So for example, the development team will be doing their web application testing. They'll be doing OWASP. So OWASP is a tool. Similarly, when you have operations team is doing monitoring, logging, IDS. Security team will be doing their infrastructure security as a part of their job. So which is you're incorporating firewalls, proxies, IPS, antivirus, APT detection. So this is your intrusion prevention. IDS is intrusion detection. Similarly, quality guys will be doing the penetration testing, static code analysis. So all these teams, when they're doing their part right, and they're incorporating security in each and every phase that they are doing, this is the whole practice of it is called as DevSecOps. So it's not just a tool in itself. It's the idea of embedding security in each and every step. All right, guys, can you just mute yourself if you are not actively speaking? Sanjeev, can you help on that? All right, let me see if I'm not sure. Sumit.
I think it's
I'm muted.
Yeah, Sumit and Chandan, right? So guys, unmute yourself so that not everybody gets disturbed. All right, so this is the whole idea of DevSecOps. Now we just had a look at DevOps pipeline. So in DevOps pipeline, so the first thing that you have is you've got your storyboarding. Then you do your coding in Git. You've got your CI, which is your Jenkins, or nowadays it's more focused on GitHub Actions. For testing, it is your Selenium, Cucumber, SonarQube. You do your SAST, DAST. You do some deployments using Docker, Kubernetes, and monitoring. Lots of different tools are available. So this is your regular DevOps pipeline that you see, right? So, but where is DevSecOps? So if you want to integrate DevSecOps, so in the same DevOps pipeline, so this is what we had a look in the last slide. So in the same DevOps pipeline, when each and every team is integrating security, this is where it becomes DevSecOps. So for example, when there is storyboarding, so you also take care of threat modeling inside the application. You also have some security concepts. So for example, when you're developing an application, you also think about what are the different types of firewalls that will be put in. Where will you be storing all the different passwords? What sort of different encryption that you will be using? So once you have your security non-functional requirements built in when you are actually doing all these storyboarding, that is a part of DevSecOps. Similarly, when you are using your Git or writing any source code, you think about the security in it. So you do code reviews, you do expression analysis, you've got security plugins built into your IDE or any sort of code editor. So this is where it helps you. Similarly, when you're doing the builds, so once you have written your code in Git, then you need to compile the code. You need to do a continuous integration. When you're doing the continuous integration, let's say you're using Jenkins or GitHub Actions, you can integrate a lot of different tools. So which is a security tools. So for example, you have, in terms of static application security, you can use your SonarQube. You can have web services testing included. So you can have automated security tests, which can be done. So this is where when you're doing your CI, this is where you include your security. Similarly, you can do some code scanning again. So when you're doing your testing, at the time of deployment, and something is wrong. At the time of deployment, you use your configuration management tools. You can use your Puppet, Ansible to manage your configuration, and so that your configuration is not manually updated. That is where you can use security in there, and also when you are using your alerting and monitoring. So Sandeep also spoke about the audit and compliance. A lot of different industries, they have mandatory compliance. For example, if you're working in a bank, there's something called as PCI DSS, which is your credit card compliance. And so the banks have to maintain some sort of security mandatorily, so from the government. So this is something that they have to do. If you're in a healthcare industry, they have got their own compliance standards. So this is something which is not just good to have. So if you are not using DevSecOps completely, you are very prone to vulnerabilities and attacks, and none of the organizations can afford it. So it's absolutely a must-have nowadays. Right. So now what happens? What happens once you learn all these different concepts, these different tools? You have multiple sort of you have learned everything in there. What do you want to do out of it, right? So what is the pathway ahead? So in this slide, I just wanted to talk about, after doing this program, what can you do, right? So the couple of roles that are available to you. The first role is your DevOps engineer. So if you're a DevOps engineer, you'll be focusing on a couple of tools, a couple of different processes. It's not that you will not be across all the tools. So you will be across all the tools, but you will be focusing on some of the tools more than anybody does, right? So if you intend to become a DevOps engineer, so the first thing that you need to understand is infrastructure as code. You need to really focus on that, because once you're doing infrastructure as code, it means that you're not provisioning your infrastructure manually. So you're using tools like Terraform, to procure your infrastructure. Tools like AWS Cloud Formation to automatically procure, use the infrastructure, and then destroy it after you have done it. You'll be focusing on CI and CD specifically. So if you want to be a DevOps engineer, CI would mean something like GitHub Actions or Jenkins. CD would be a tool like Urban Deploy, Code Deploy, right? You'll be focusing on automation. So you have to be pretty good in writing the scripts, writing Python. You will have some good understanding of programming languages. So because a DevOps engineer would be working very closely with the application engineers, right? So if an application is, let's say, built on React JS, if an application is built on Python or Java, you should have certain understanding of it. You may not be the master of programming language, but you need to understand the programming language because then you are doing the CI and CD process for it. Deployments, similarly, if you are building the tool, so you will have to do those deployments of the packages that the application team has built. And collaboration is anyway a part where you will have to play along with the different application teams. So these are the basic tasks of a DevOps engineer. So infrastructure as code, CI/CD, automation, some sort of programming, deployment, and collaboration. For those people who really do not like programming for some reason, there are still many roles open. So the other role that you have is your SRE, which is Site Reliability Engineering. So Site Reliability Engineering, this is less of a programming role. A DevOps engineer is a little bit more of a programming role than SRE. The SREs will be dealing mostly with SLOs, so which is your service level objective. So for example, let's say you have an application and you want to maintain the uptime of an application. So you will have to work with the different sort of load balancers. You will have to work with the alerting and monitoring capabilities. You'll have to see that your application is, let's say if an application has an uptime of 99%, you have to ensure that that application is running at least 99%, right? So we'll be working on the SLIs, SLOs, SLAs. We'll be telling you more about all these different definitions and how to measure them in subsequent sessions. Site reliability engineering has to do with reliability of an application. You monitor the application using different tools. For example, like Nagios, you got Dynatrace. There are multiple tools available. You have to maintain the availability of the application. So this is directly related to your SLOs. If there are any problems in the application, you have to deal with the incidents, informing the right team that some problem has occurred. So this is the primary role for an SRE. So this is less of a programming, it's more of a configuration and keeping an uptime of the applications in terms of all these different aspects. The third role that you can target is your platform engineer. The platform engineer is pretty much similar to SRE, but it's to do with your service orchestration. So for example, you have lots of microservices, you've got API integrations. So one microservice talking to another microservice. So what are the ports that they will be using? What are the different sort of, well, when we are talking about cloud, you'll know more about VPCs, subnets, the different types of NACLs, encryption, security. So that is the job for a platform engineer, to maintain that the application is secure. What are the different clusters that the application will be running? So we'll work through this when we are in the subsequent sessions. Cloud infrastructure, procuring the infrastructure. What are the different clusters? How you're procuring them. So this is all in Terraform. So Terraform is a major part of your platform engineering. Containerization, working with Docker and Kubernetes. Scalability, load balancers, your auto scaling groups, and your ALM. So these are the three roles that you can target after once you are familiar with all the different concepts that we have told. And if whichever path that you choose, you will have to work in detail in those technologies, because so if you look at this slide, it's impossible to be a master of all of them, right? So there are so many different tools. So what you can do is you pick and choose which field you want to go in, and then deep dive into the specific tool. So if you are into SLOs, if you are into your site reliability engineering, you will be doing more of these monitoring stuff. If you are into DevOps engineer, you will be doing more of these DevOps engineering stuff, right? So depends on what you want to be, and this is why it is important. Which tool would you like to focus? There's another role, cloud engineer. So we had a look at DevOps engineer, we had a look at SRE, we had a look at the platform engineer. So this role is cloud engineering. Cloud engineer is a little bit different than any of those three above. So cloud engineer is mostly when you have an excellent understanding of any one cloud. So whether it be AWS or GCP or Azure. So it's everything to do with what are the different services that are involved in and which help you build an application using cloud. So services that you can use for programming. So for example, let's say if you're using GitHub Actions, how does it integrate with cloud? How do you actually do the containerization? How does the networking behave? So when you are connecting one microservice to another, how does it happen in the cloud? DevOps is obviously a part of it. Database management, when you're using cloud services, you're using, let's say, RDS. We'll be working through each and every component in detail in the subsequent sessions when we're doing AWS. So you've got APIs, virtualization, web services, security recovery, and everything runs on Linux. So like 99% of stuff in organizations, they run on Linux. So it's essential. So whichever role you choose, so whether it be a DevOps engineer, SRE, platform engineer, or a cloud engineer, Linux is the absolute essential that you have to know. So this is a skill which is non-negotiable. And you have to, if you are not familiar with Linux, so this is the first thing that you have to do right now. So this is a role which you can also target after completing this program. Now, if you have been in the industry for a while, if you have already been a DevOps engineer or a cloud engineer, and if you are at a senior position, there are a lot of architecture-based roles that you can target after this program. So you have business architecture, you have got enterprise architecture, you can be a chief architect, software architect, data architect, application architect. All these different architectures, they deal very specifically in their domain. So for example, the business focus architects, so they will be working towards the organization goals. So this is a very holistic role where you're not looking at an application, but you have a very deep understanding of how the applications interact with each other, where your organization is going. And then keeping in mind a 20,000 feet view of the organization, you design the different sort of technologies that will be used across the organization. So all the architects, though they are very senior roles, but this is probably one of the senior most among all of them. So enterprise architecture and business architecture. If you have been in the industry for a while, you can choose to be a software architect, data architect, or an application architect. So these are developer-focused roles. So you will be working in detail inside individual applications. You'll be working across the different layers of applications. So whether it's a UI or whether it's a database or whether it's a business logic, and then you will be working your way in. There are specific technologies which go in depth. So data architect is different than a software architect. Application architect and software architecture are almost very closely aligned with each other. The third role that you can target is your operations focused. So where you are cloud architect or security architect, network architecture. So these are still go deep dive into application, but they're at a horizontal level. So not one application, but you see a series of multiple applications and then you apply your architecture across it. So it can be a site reliability engineering or network architecture. And the last one is your vendor focus. So where you deal with the SaaS services. So once we are doing in the subsequent sessions, we'll have a look at the different SaaS, PaaS, and IaaS solutions, and that is where your vendor focus. This architecture roles are pretty senior roles, so you need to have a very detailed understanding of what a layout of an organization is, what are the different applications across the board, and then you work your way through. So these are the four kinds of streams that you can target in DevOps, right? So just reiterating again. So DevOps engineer, SRE, platform engineer, cloud engineer, and then after you have done all these, or you have got a very good amount of experience, then you can move on towards the architect roles. All right, before I move on to the next slides, any questions so far? Sorry, I'm not able to see the hands. Yeah, Tariq.
Yeah, thanks for the intro, Surab. So just to assess my understanding, when it comes to the DevOps, are we like defining the whole process? So we are like guiding the organization toward all these pipelines. Okay, you should have, for example, this this planning and building, and then so we are defining the process. This is a question. And just jumping back to the last role that you described, because as I mentioned, I'm coming from cloud architecture perspective. I can capture one of my focus, and my attention is more related. In my case, as an architect, I'm responsible for producing some infrastructure as a code.
Yep.
So we can mix and match. It doesn't mean that, for example, I am doing coding, then I can use the same experience and put it on the cloud architecture. So there is some mixing and matching that can happen, I believe.
Absolutely.
Yeah.
Absolutely. So if let's say if you're a cloud architect, you cannot be a good cloud architect unless you know about security as well, right? So
exactly,
these two are interchangeable skills. Sometimes you do a deep dive into the cloud services. So what are the different types of services? The cloud architecture would also define what service to use. So sometimes, let's say you have got an application which is running, you would have to come across a decision whether you will be using serverless or whether you will be working on a VM, right? So that is one of the. So when you are using your databases, do you select RDS or do you deploy your database on an on-prem system? So these are types of decisions, but all of them are pretty closely integrated with each other. A security architect would know everything about cloud, but they'll be focused more on the types of encryption, the types of firewalls that you'll be using, what are the ingress controllers, egress controllers, how the traffic will be coming inside. I'm talking about a few words which we'll be learning in the subsequent sessions. But what are the different sort of clusters where the traffic will be coming in? Would you be having ingress controllers? Will you be having ingress firewalls? So this is where your security architect will come into picture, and the security architect will start policing and questioning the application, whether they have incorporated all the best practices or not. Similarly, you've got automation architect. So what are the automation tools that you'll be using? What are the best practices you'll be following? So each of them, they would know few things about each other, but they'll be an expert within their own domain, right? So for example, network architecture, what are the different networking protocols will you be using? So would you be using gRPC, or would you be using, what are the different ports that you'll be using? How will your network be managed? How is the traffic flow happening between one system to another, right? So what are the different firewalls that you will be using inside? So all of them are to be used in conjunction with another, but focusing on their individual tasks.
Yeah, but the DevOps will jump into the depth. It is not just a role that you will define the process. That, for example, if we are talking about the planning, then the DevOps is not proposing something for the organization, and just it is like a high level role, let's say. No, it is
Yeah,
not a
so
high level. It's not a high level role. It is a role that you need to specify, as you mentioned, you need to specify which direction you need to follow. And maybe it depends on the organization, because as I said, in my organization, there is a mix between, I'm a cloud architect, but I'm responsible for producing those infrastructure as a code and all this stuff. And maybe this is the aim, because I'm a cloud architect, but I'm not to the depth of understanding the Terraform. I'm just playing with the Terraform on a high level.
Yep.
So I'm jumping in to this course to understand the Terraform and to understand how to produce the code and all this stuff.
Yep.
Sometimes it's like not a strict line between each and every role. Really, it depends on the organization.
Yep.
But I believe I can capture this information if I'm coming to this course to understand
Absolutely, because as I said, that this course will cover each of these streams.
Yeah.
So if you are interested in knowing more about infrastructure as code, so you can focus on that. So if you're focusing on the DevOps engineering side, it doesn't mean that you will not be working as an architect. So it will enable you to have a deeper understanding inside each of the service, and then make use of it in your day-to-day job.
Okay, thank you, Sarab.
All right. Any other question? All right. So why I actually shared these slides is because it's a very common question that do I need a lot of programming to do DevOps? What exactly is DevOps? What are the different streams that come out of after learning all these different tools? So you can pick and choose the different types of focus that you want to do, and then work on these different types of roles, right? So that's what is the idea behind it. All right. So the next one. The next slides, I want to talk about what does it mean to be a DevOps engineer in an application. So there are multiple tiers of application. If you look inside an application, most of the applications that you will see will have certain sort of architecture in it. So for example, if you have just a very basic website, so it's a 3-tier application architecture. You can have a presentation layer, so where you capture some sort of data from your web page. You can have a logic layer inside the server. So once the traffic is captured in your UI, you send the traffic to your logic layer, and then you got a database. So this is a very typical example of a common application, right? So if you see the presentation layer, so DevOps do not have to do anything with the presentation layer. So the presentation layer can be built up in either HTML, or you can use React or Angular. So the DevOps, they do not actually do anything with the presentation layer. So these layers, this is just created by the developers and then put onto wherever it is being deployed, right? So typically it is handled by the front-end developers. In the logic layer, you will find that the DevOps engineers are engaged. So they're required to do the CI, the CD, manage the security part of it, creating the middleware, creating the application servers, managing the APIs. So this is where your DevOps application engineers will be working. Involved in creating the databases, managing it, creating the roles and roles-based accesses across the database. Who will be having access to read access or write access? So defining the different sort of roles and responsibilities. So in a 3-tier application architecture, so DevOps engineers will be primarily involved in the logic layer and in the data layer. Similarly, you can also have a 4-tier application architecture. So in this application architecture, you will have something extra called as a web server. So if you see here, so you've got a presentation layer, you've got a logic tier and a data tier. But in a 4-tier application architecture, you will see that there's something called as separate a web server, which is an added responsibility. The presentation layer, in the same way as 3-tier architecture, it's typically handled by the front-end developers. when there is a web server included in an architecture, so the DevOps engineers will be managing the auto scaling, the web server scaling, the load balancers across it. So that is more of an infrastructure part which the DevOps engineers will be taking care of. In the business logic, so depending on what the logic is, so there can be some message queues, service buses, or use of S3, Lambda, different sort of serverless components. So that is where not only the infrastructure, but role-based access controls. They'll be working very closely with the cloud services, and that is where the DevOps engineer will play their part. And the database is the same as in the 3-tier application. So this is where the role of a DevOps engineer would come up when there is a different types of application architectures. Now, thinking about architecture, so initially there was something called as a monolithic architecture, and this might come up in an interview sometime as well. That what is the monolithic architecture? What are different microservices? Now, DevOps per se, a monolithic architecture is a legacy now. So if anybody is writing any application, they are not writing a monolithic architecture. But what is a monolithic architecture? Monolithic architecture is something like there used to be big sized applications with like a single blob of an application which you just deploy somewhere like on a server, and all the components are inside that application itself. So if you are supposed to update an application, let's say if this application, even a small component needs to be updated, then the whole application will have to be updated, right? So this is one big monolithic architecture where all the applications inside it are tightly coupled, they're all assembled together, and then you release it at one go, right? So, but this is no more a practice now, and we'll talk about what is a microservice. So the monolithic architecture would have some sort of UI, a client-side UI. It will have one database and a big blob of compiled programs. But it had its own drawbacks. We'll have a discussion on that as well. So similarly, a monolithic architecture example. So these are not any more being followed in practice now. So this used to be done earlier, where let's say if you've got multiple services, for example, like customer service on a website or product service, or you've got a shopping cart, everything used to be inside one big binary file. Right. So let's say if it is a Java package, so it used to be inside a one big binary file. If you need to update the cart service, make some changes to it, you will have to compile the whole software and then release it. Right. So this is what used to be a monolithic architecture. The challenges for monolithic architecture was that it was very inflexible. So if you need to update something, you will have to update the whole blob. It was very unreliable, unscalable. There would be no continuous development because multiple teams cannot work on it. So because the whole team will be working towards creating one big package, right? And that's what it will make it slow. And this is one big, large and complex application. That used to be a big drawback. So that is where the whole microservices concept came into picture. And then we started up using a microservices architecture. A microservices architecture is you break down the single one big blob into what are the different services in it. So for example, in this monolithic architecture, let's say you got a customer service example, you got a product service, and you got a card service. So these are the three services. You can break them down into individual services, into individual components, and then call it as a microservice so that individual components can be developed by different teams and then they can be built and deployed. So that was the concept behind the microservices architecture. So each of the application can be a part of your microservice. You create multiple microservices, you integrate them together, and then you deploy them individually, right? So not one big blob gets deployed, but let's say if you're just updating a shopping cart service and that is microservices 3, you don't need to touch upon 1, 2, 4 or any other service. You just deploy this service. So this used to be a pretty quick, and this is how all the any sort of application nowadays that are being built, and the DevOps engineers will be really responsible for them. They're all about microservices. So similarly, as I said, so if you have got one big application, so there can be multiple microservices in that application, and each of them, so for customer, product, or cart, so if it's a shopping website, so you have got individual microservices. Each of them will have the whole DevOps process inside it. So everything that we see, source, you've got a source control, you've got CI, CD, and then you've got DevSecOps in it, monitoring, alerting. So each of these life cycles that we saw in DevOps will be applicable individually across each of the components. So that is where your microservices and DevOps interact together. The same view of that. Now, just to be sure of what are the different basic differences between monolithic and microservices architecture, there are a couple of points here. You can go and read about them all. These slides will be provided to you. But in a nutshell, microservices architecture, these are small independent services. They can be deployed independently. They can scale horizontally. So if you need, for example, in this service, if there's a big load towards a customer microservice, you can just scale this particular service independently, right? So you can have multiple VMs allocated to this service itself if there's a big influx of traffic coming in. So similarly, it's easier to test individual services. The failures are isolated. It's easier to implement the CI/CD processes and all that stuff. So that is where is the difference between monolithic and microservice. And DevOps processes nowadays, whenever you're working in an organization, 99% of the times you will be dealing with microservices rather than a monolithic architecture. So few of the last things that I wanted to talk about in terms of your application. So there are multiple types of architecture that you will be working with. And we'll be working with these different types of architecture. We'll be discussing about them in the subsequent sessions and as we are working with this course. So the first is your solution architecture. So this is so there are three types of architectures that I want to tell you. So the first one is your solution architecture. In here, you will have the different types of presentation layers, the client layer, business layers, data layers. Now, this is just a sample, but you will need to understand the view behind this particular architecture. So these are mostly component level diagrams. So for example, you will have mail clients or browser-based clients, which are communicating with the presentation layers, and then it is communicating with the business layer. So and because this is just a sample, I don't want to go into the depth of it because there's no point, but this is just a view of a component level solution architecture. Similarly, the same solution architecture can be viewed in a different lens. So if you look at the same architecture of an application, if you look at the network architecture of the same application, it will have a different view than the earlier one. So the earlier one that you saw was a component view, right? So for example, you have got mail clients as a component. You've got browser-based clients. There will be some sort of communication which will be happening. There will be some sort of portal server which will be a part of the application. But if you look at the same application from a different lens, you will find that the network architecture looks something like this, right? So the network architecture will not be talking about the business components. The network architecture will be talking about what are the different and we'll be learning about all these things in detail when we are doing the cloud infrastructure part, right? But just to be aware that a network architecture view of the same application is different than a component architecture view. So in here, we'll be talking about what are the different firewalls, what are the different gateways, communication gateways, what are the other we'll be talking more about VPCs and flow logs and what these guard duty and everything that we'll be using up. But just be aware that a network architecture of the same application will be different than the component architecture. Similarly, we'll have an infrastructure architecture view of the same application, which will be different than the network architecture. So this view is of the same application, but it looks pretty different, right? So, and I do not want to confuse you by going with the details. We'll be learning more and more about it in the subsequent sessions. But this is the infrastructure architecture view. And similarly, there is something called as security architecture of the same application with a different view of it. Now, why it is important to understand all these different ones, it's not essential, but if you want to be a robust engineer who want to contribute to your organization, it's very good if you understand all these different parts and the different views of it, so that when you're talking to your senior stakeholders in an organization, they would really appreciate the depth of your understanding when you're talking about all these different things. So these are just the different lenses. We'll be talking more and more in detail about each of these when we are discussing in the subsequent sessions. But just understand that there are different lenses which can be applied to an application. So this is your component solution architecture, network architecture, infrastructure, and security. Right. So this brings to the end of the presentation that I had. And if there are any questions, I'm happy to take that. What just Have any questions, anyone? Am I audible?
Yep. Yes.
Yep. Okay. All right. So this is what I had for presentation today. So we had a look at the different types of applications that we'll be dealing with, the different types of DevOps practices. And we also had a very brief look at the different types of DevOps tools that are available in the market and what we'll be focusing on. So the next session that we'll be having, so we'll be focusing on Linux Git. That will be starting with. So that will be the next session. If you want to practice, and if you do not have much idea about Linux, it's a very good time to start working on Linux. At least run through. So we'll be working definitely with some of the shell scripts and what Linux is. But it's a good idea over the week that you just check out your Linux skills and work with it, because everything in cloud it has to do with Linux. All right, so that is all that I had to share. Yeah, Murli, you have got a question?
Yes, I have a question. So the sessions that we are going to have going forward, right? Would it be more of this PPT kind of presentations, or would it be practical kind of presentations where
Yeah.
someone logs
So
in
they,
also?
yeah. So today there was nothing to actually do a demo on the software. So, but the subsequent sessions that we'll be having, it will be a mix of PPT where we'll be telling about your theoretical concepts and fundamentals, and then we'll be showing you the demo as well. So it will be a both.
Okay, thanks.
Yeah. Chandan, you got a question?
Yes, I've come across this term called edge computing. What can you just briefly tell me what exactly it is, and where does it fit in this overall thing?
Yep. So let me see. Edge computing can have different meanings. Let me just check what is the context behind it. One of the edge computing would mean something like a CDN. So which is your content delivery network. So for example, if you have got a website, and you want to make sure that your website is very responsive. So you can use some of the cloud services like CDN that would help you to manage the latency, right? So that is what the edge computing would mean. You would also be able to utilize a better bandwidth, make sure that the website is available everywhere. You will be able to handle the static and the dynamic components inside that very differently. That is what would be the edge computing. So it's more about the distributed computing, and from wherever the user is accessing an application, that there is a network edge which is near to that user. So that is what is the edge computing.
Okay. Primarily used mostly for, your
In cloud services, you would use something like a CDN, so which is content delivery network. If you just have a look at what CDN is, so it's a service inside cloud. You just apply it to your application, and it makes your application geographically uh, at a very less latency to the network.
Got it. Okay.
So,
thank you.
all right, Tarek, you have got a question?
Yeah, I'm a little bit concerned now because I'm coming from 20 plus years experience in Microsoft and that's it. So I'm afraid now I should leave because you mentioned that the Linux is a mandate. Because from my angle, maybe it is limited a little bit. When it comes to what I am dealing with, the people around me are always dealing with specifically with Azure, let's say, and maybe across the whole experience with the cloud, nothing came to me directly and said to me, you should understand Linux to the depth, or even maybe you need to deal with it. So just I'm a little bit concerned about the Linux experience, and not for just defending. No, just I need to know more. What should I prepare myself, especially in my case with 20 years experience with Microsoft. So if you can guide me where to look, that will help me across the course, how I can progress well with it. Yeah, please.
So Tarek, my question to you is that how have you worked 20 odd years without an introduction to Linux?
Across the experience, it was like I was a Microsoft engineer. When I go to the companies, this was my role. I was like a very dedicated Microsoft engineer, Microsoft cloud architect. So yeah, there were other teams dealing with Linux, but across my experience, I've never got the chance to. I know the Linux stuff, but maybe on the early stages. But across the previous experience, it was all Microsoft. Nothing came to my responsibility to deal with Linux. Yeah, this is why I'm concerned. And even with my current role, sorry for interruption, as a cloud architect, I continued with Azure. Yeah, I know the stuff switched a little bit toward, let's say, coding, but nothing came to my attention or my responsibility to say you should study Linux. This maybe I raised the question not for the sake of how I should progress properly with this course, not to be against the idea itself. Yeah.
So if you remember the slides that we were talking about in terms of where you want to be. So if you are targeting a role of a DevOps engineer or SRE or cloud engineer, you will have to work with either of the Unix flavors. But if you are targeting the role of an architect, probably not, because you will not be doing a lot of hands-on. You have to be more conceptually involved with the with an organization, what sort of applications they are dealing with, and have an understanding of the networks, the security. What does it mean when you're integrating an application with your APIs? So you have to understand that at a conceptual level. If you are an architect, you don't really need to go and write the Terraform code or write CI/CD pipelines or even create routers, right? For that matter. So if you are not heavily involved in writing all those applications, you may not need to be in depth in Linux, but you need to have an understanding of how it all hangs together.
Yeah. Also, I need to mention something. In my situation, there is like a differentiation. Maybe the scale of my organization currently is huge, little bit, and there is a room for splitting between the platform and the application. Yeah, they integrate somewhere, but in my scope, I'm focusing more on the platform and maybe what you presented with the networking architecture, with the infrastructure architecture that matches to what I understand really. And yeah, just I'm mentioning this for the sake of information for the other audience, that you might face some cases that you are dedicated for the platform, which is the infrastructure, let's say, and sometimes you will go toward the application. So in my experience, the DevOps can go to either directions. It doesn't mean that I should be specialized with application or I should be specialized with the platform.
Yep.
It depends where the organization is. Yeah.
Yeah.
Mhm.
And it depends on what your role is.
Yeah.
So not all roles require you to be hands-on. Some of the roles, like architecture roles, they are more conceptual and fundamentals related. You should be knowing what you're talking about. You should be having you should have the capability to understand a 20,000 feet view of the application, as well as going right into a deep dive and
yeah, but in my case, it requires, because it is some sort of engineering in it. Let's say I need to produce those artifacts. I need to produce the blueprints. So I should talk about the concept and how we architect the
So
whole solution.
I would suggest that you start having a look at Linux, how it works, because that would really help you out.
Yeah, if you can guide me to some foundational stuff.
And then
I appreciate.
the next session we are going to have it on both Linux and Git. I'll be able to tell you more about in the subsequent session, but you can just check out any YouTube or any other forum for that as well. So in the meanwhile.
Okay.
Yeah.
Thank you.
All right, Rama, you have got a question?
Hi, Saurabh. So you spoke about the monolithic architecture and then the microservice architecture. So I'm hearing the concept like the serverless concept. So is it something related to that, or is it a whole different concept?
So serverless is something which is so serverless is nothing but it's similar to like a virtual machine, but you do not procure the server. So your code is running somewhere. So for example, you've got serverless like Cloud Functions, Lambda. So your cloud provider would give you an infrastructure to run, but you do not manage the infrastructure. So that is what is serverless, right? So your code is not running without a server. It is running on a server, but you don't procure it. All you do is just upload your code and leave it on your cloud provider to run it. These are all a part of microservices itself. So none of them is monolithic. So any subsequent discussions that we will be having in any of the forums, so that will all be involved with the microservices. And the whole cloud concept is based on microservices architecture.
So my subsequent question would be like, if we are managing, if we are managing our own microservices, so we manage our Docker instances and Kubernetes clusters and everything, but in serverless we don't do that. So we just upload our code, and all the infrastructure will be taken care of by the. Okay, all right. Yeah.
You don't manage a Kubernetes cluster. Instead, if you have a Docker container which is running, so you upload it in your ECS, which is Elastic Container Service. So that is a serverless.
Okay. One more question I have is, so I work for Oracle and for past 10 years, and I've been working on Oracle Cloud. So I'm not much aware of AWS or Azure because we don't use that. So obviously, so how much are the skills like the Oracle Cloud skills interchangeable or easily adaptable with the AWS and Azure, or will that be a huge learning curve who is coming from the
I
Oracle
have
Cloud?
not worked on Oracle Cloud, neither have seen one, but I have worked on AWS, I've worked on Azure, and I've worked on Google Cloud. And I find that the skills are interchangeable in them. So it's just the terminology that changes. So for example, you call the same thing as Lambda in AWS, but you call it as Cloud Functions in Google Cloud. Right. So I would imagine that your Oracle Cloud would not be fundamentally different than any one of them.
Yeah.
Just the
Okay.
services would be different. Name of the services. The basic
Okay.
concepts would be very similar.
Okay. So, so if somebody coming from this, I mean, like some example like Oracle Cloud or something, and if I'm applying for another role which uses AWS or Azure, so how does the market respond to that? Like, do they? It's a very generic question. It might be specific to each company, but in your experience, how have you seen the interviewers or the companies looking at? Are they mostly looking at your skills or your understanding of the concepts, or your understanding of like okay, we are using AWS, I need somebody who definitely knows AWS?
Yeah. It depends on your skills actually. So let's say if there is a Google Cloud requirement and you are an expert in AWS, companies do hire an AWS professional to work on Google Cloud, and same for Azure as well. So if you are an expert in one cloud, you would not take any time at all to be an expert in the other one as well. The concepts are fundamentally similar. It's just the terminology that changes. And if you are excellent in one cloud, and if you have an in-depth understanding, the companies would hire you for another cloud as well. So
Okay.
that's been my experience so far.
Okay. Yeah. All right. Yeah. That's all my questions for today. Thank you.
All right.
Yeah.
Thank you, Ram.
Yeah.
Murli, you've got another question?
Yes, I have another question. So in one of your slides, you highlighted a few roles, right? So at the end of this program, would I be in a position to apply for any of those three roles, that's DevOps, SRE, platform engineering, or
Yes.
do any specific concentration?
So throughout this course, so we'll be discussing about each of these tech stacks that we talked about, right? So we'll be working on CI/CD, we'll be working on alerting monitoring. So we'll be working on Terraform, Ansible. Now, and that is the reason why I shared this slide, was depending on your career path, you can start doing a deep dive on the specific technology. So for example, if you intend to be a SRE engineer, then you would be focusing more on your Terraform, your alerting and monitoring, rather than going deep dive into GitHub Actions or Jenkins, right? So that is where you start picking and choosing your technology and where you want to be in terms of any of these roles.
Okay, so at the end of the program, maybe I just wanted to get into SRE, which means I have to concentrate more into monitoring and then apply for jobs.
That is correct. So you'll be more involved into alerting and monitoring, keeping an uptime of the application, availability, scalability. So you will be dealing more and more with cloud services and your Terraform for the infrastructure, and also the alerting and monitoring, right? So like, for example, learning to use Dynatrace or CloudWatch, what are the different types of metrics, traces that you can use. So once we are covering them all in the subsequent sessions, though you would need to have a fair understanding of the others as well. For example, like you need to have fair understanding of what is CI process, what are the different types of SAST tools that are being used. But you don't need to go essentially to the very core and in-depth and very deep understanding of CI/CD then. All you need to do is you need to understand that, okay, this is what CI means. This is what you do when you're doing the deployments. But essentially, as an SRE engineer, you will not be involved in those activities. You will be involved in maintaining the uptime of the application, and that's where you will be focusing on.
Okay, thank you.
All right, Chandan, you have got a question?
Yes, sir. So the 4-tier architecture that you explained, I did not quite get the difference between tier 1 and tier 2, the user interface and web server.
Yeah, so, yep. So,
can you help me explain that again? I thought
yeah.
always tier 1, the web server would do the presentation logic as well.
Yeah, so if you have a 3-tier architecture, so let me just open up the slide again. So where is... I'm just opening up the presentation again. So, and are you able to see the screen?
Yes.
Okay, right. So 3-tier architecture. So this is a very simplistic architecture now. So for example, let's say you are building up a Python application, right? So a Python application you can build up without a web server. So you can have something like a Flask application. So wherein you're running a Python Flask, and then that will give you a presentation layer itself. So Python application without a 4-tier architecture would look like you've got a Python which is in the business logic. You've got Python Flask without a web server, which is you're working as a client, and then you've got a database. So that is a very simple Python application with a 3-tier architecture. For a 4-tier architecture, so for example, if you again have a Python application and you've got a variety of complex, let's say you have got React or Angular JS, where you are capturing your user interface, then you would need something like a web server, which can host it and then present it in the at a UI. Right? So that is where your web server would be involved. So even if you're using Apache or HTTPS and you're presenting up a web page, so that becomes a 4-tier architecture.
So in terms of, okay.
So you can have you can have a presentation layer without even a web server as well. Right. So for example, in earlier days, there used to be something called as a Visual Basic. So Visual Basic would actually communicate with the business logic. So in this 3-tier architecture, your application is capable of having a UI interface. So without a web server. So that is your 3-tier. Most of the architecture that you would now see, they are 4-tier architectures. You would have a web server, you would have a user interface. Your user interface might be written either in HTML or it can be written in React or Angular JS, and then hosted on a web server, which will connect to your application server.
Okay. Thank you, Saurabh.
Go to the microservices architecture, so please.
All right. So any last questions?
Please, is possible to have this slide so that we can go through?
So this slide will be shared with you on Slack as well as in the mentorship WhatsApp group. And also, so one more thing. So everybody, I hope everybody is on Slack. Is there anybody who does not have access to Slack at the moment? So if you don't, just contact myself or Sanjeev. But there is a mentorship guide on Slack where you will get all the previous links of the sessions that we have conducted, and that is what you can use to actually get ahead in the program as well. So let's say if you already have a lot of conceptual knowledge, and this is where we have got multiple types of people in the same group. So where, as I said earlier, some people are freshers, some are very, very advanced levels. So if you think that you are already at a very quite an advanced level, it's not a bad idea to start project directly, because then you are not waiting for all the classes to happen. You already have an understanding. You can follow these sessions at an advanced level, looking at the previous recordings. So there are also projects which are already done. They are all available in the mentorship guide. You can start following the projects and accelerate yourself. Also, the next subsequent sessions that we have, so we have already previously conducted these sessions. So you can have a look at those sessions in advance. So they're all available in the mentorship guide itself. So you can have a look at these, what is coming up. You'll be able to better equip yourself with more matured questions. You would know what is coming up. So there'll not be any surprises to what are the different topics or what we'll be covering in it. All right, guys. So the next session is on Git and Linux. So it would be good if you can watch the previous session from if you can watch the session that we covered in Git and Linux beforehand. So the links are available. Otherwise, you can just keep up with the live sessions that we have, and that would be also good enough. Yep.
Where do we get the links?
Kelechi, I will send you the mentorship guide if you have not received it.
Okay, thank you.
It's in the resources section in Slack. So there will be a resources channel, and in the resources channel, you'll find the last message in there would be the mentorship guide. In that,
Okay.
there's all the links. Tariq?
Yes, Surab, if you can give us a guidance for me, the Slack is the first time to use. So just a guidance on the Slack, how we can interact, where we go on the Slack.
So
and another, one question for the session that comes in the middle of the week, which happens on Wednesday. What your advice from what happened from the previous? I should attend it, or what it will help me, or where to utilize it, or when to
the
utilize
sessions on Saturdays, they are more or less quite mandatory because these are very focused learning-based sessions. So we did not cover a specific technology today, but you will see that all the next Saturday sessions, they will be very targeted learnings based on a specific tech stack. So don't miss out on the Saturday sessions. The Wednesday sessions are very optional sessions. So if you have any questions, specific questions, now Wednesday, these are just random discussion sessions. If anybody has got any interview lined up, they want to discuss about whatever is the job description. So we can talk about what are the different potential questions that can be asked in an interview. Or if you have any career related questions, or if you have any technical question that you have come across, or any sort of doubts that you have, that is Wednesday sessions are very random sessions because we want to keep the Saturday sessions very targeted. And so if you want to have any discussion that you want to take up in any direction, that is what the Wednesday sessions are for. But if you do not have any specific questions, you can choose to miss it up completely. And that's all right.
Okay. Yeah. So the other portion is related to the Slack. If you can.
And Slack is Slack. It's just have you logged into Slack?
Never. No, this is the first time to see the Slack. Yeah.
Have you logged on now?
I am opening the. Can I share my screen, or if you prefer to share?
Don't share your screen. That's fine. So in Slack, if you go, you will find a couple of channels.
Yes,
so there's a DevOps and Cloud channel. There's a resources section. It's very self-explanatory. So it's as easy as just learning to use WhatsApp. So once you get a hang of it, it's very organized.
Yeah. So when it comes to the slides, I will find it under the resources.
You'll find all the communications being done in the there's this DevOps and Cloud channel. So you'll find them all in there.
With the slides, with the previous sessions, everything is under the DevOps and the Cloud. Okay.
Yeah, the previous sessions will be all under the resources category.
Okay, so this where I can refer for the previous sessions.
I will send you a message after this session.
Okay, I appreciate it. Thank you.
To yourself and Kelechi. Yep.
Okay.
Yep. And everybody else, if you are not sure of, just ping me or Sanjeev, and we'll let you know where it is. All right, guys. So that's all for the introduction today. The next sessions, they will be pretty serious, and we'll start doing deep dive into each of the tech stacks in the subsequent sessions. And all right, I'll see you all in the next session then. Thank you for joining today.
Thank you.
Thank you.
Bye.
Thank you. Thank you.